In this problem, we're going to look on how a change in pressure affects the volume of a fluid. And notice we're given two values here. We're given the bulk module, which is a module that deals with volume, and we're told that it's 5.0 times 10 to the 9th Pascal, and we're given something known as the compressibility, how easily it is to compress a liquid, which is 1 over the bulk module. But notice that we're given different units of pressure here, and that's going to come in to the solution in a little bit later. But keep in mind that pascals and ATMs are different. We have 1 ATM is about 1.01 times 10 to the 5th Pascal ATM for atmospheric pressure. So depending on which units we're more comfortable using and which units we want to work with, there is a formula that says that the change in volume is the same as negative the original volume times the change in pressure over the bulk's module. And the negative is because an increase in pressure will result in a decrease in volume, or a decrease in volume will, a decrease in pressure will increase the volume. So there's always that reversal relationship between these two. So we're told that the original volume is 0.25 meters cubed. We're told it's an increase of pressure, so a positive 1.6 times 10 to the 7th, 1.6 times 10 to the 7th Pascal, all over the bulk module, which is 5.0 times 10 to the 9th Pascal. And if we do this, we get about a negative 8.0 times 10 to the minus 4 meters cubed. Now, another way we could have done this is by looking at the fact that the change in volume is the negative compressibility times the original volume times the change in pressure. So if you want to use the bulks module, you can. If you want the compressibility, you can. Notice that because the compressibility is the reciprocal of the bulks module, if you have one of them, you can always find the other one. So we're told that the compressibility is 20 times 10 to the minus 6 ATMs to the negative 1, original volume. Because we have ATMs now, we got to be careful when we're using the next part in this equation. In order for me to use this equation with ATMs, I need to make sure that the delta P is in ATM, so I can put 1.6 times 10 to the 7th Pascal, but then I have to multiply this by 1 atmosphere is 1.01 times 10 to the 5th Pascal, and that will give me ATMs, and that will make the equation work. And if I do this, I get exactly the same as what we did before, which is the negative 8.0 times 10 to the 4th meters cubed.